All right, so before we get started, there's a paper. I'll grab that before I forget. And then open up to chapter 9, please. I'll give you a page number here in just a moment. Just make sure your names are on them. These three have them. Okay, thank you. Okay. All right. Need to get a few more steps anyway. Okay, thank you. Righty. So let's see here. About page 310 is where we'll start converting mass to mass problem. Because notice from up to this point, we were doing 2 and 3 step problems. Now we add one more for a 4th step, because we may start with a mole of a substance and convert it to moles of another substance. That's 2. Then a mole to a mass, that is 3 steps. And then finally, if we're going to go from mole to mole, that will be ultimately 4 steps. So there are some examples, sample problem E, that you can go back and read should you choose to. Okay, so as we continue, all right, on page 311, okay, do you want to pick one, or would you feel comfortable already? You give me some input. Page 310, 311, sorry, excuse me. Okay, there are problems on page 311. Said there's 1 through 3. You want to pick one, or do you feel comfortable not doing it? So I said I asked for some input, and here we are. Okay. Number 3 says, okay, what mass of aluminum is produced by the decomposition of 5 kilograms of aluminum oxide? Okay, so again, notice you're not always going to be given the equation. They give you the substance that you're starting with, which is aluminum oxide. Now, what do you suppose you have to do before you even start writing any numbers down for that? Because how much of that aluminum oxide are you beginning with? What does it tell you? 5 kilograms. Okay? What do you need to change that to? Okay. So here again, this is one of them aspects to where you kind of cheat a little bit and say the answer is supposed to be 2.6 kilograms, which would be how many grams then? We need to move that decimal any. how many times larger is a kilogram than a gram? 1,000 times. So if that's a power of 10 from 1 to 1,000, how many powers of 10 is that? 3. So you multiply 2.6 by 1,000, you move it over. So this should be our answer, 2,600 grams of aluminum. But we're beginning with how many grams of aluminum oxide then? If it says 5 kilograms, that would be how many grams? $5,000. Okay? Okay, so that's what we're starting with. That's the first conversion that you need to make. All right. So, next thing, you have aluminum oxide. And that decomposes. So, what does that mean within a decomposition reaction? What happens to the right side? Okay? So, if it breaks down, we've got this. So, is that written correctly right now? No, it's not. So the next thing we should do is what? Yes, oxygen's a gas, so it is diatomic. So we're getting closer. Next thing, need to balance this. So, okay, 2 here. All right. So, now, with this, we've got 5,000 grams of aluminum oxide. The question was asking, in this decomposition reaction, how many grams of aluminum are going to be produced? Okay? So, does this help you, just for future reference, does this help you out when we do that? Or could you not care less whether we put that up there? You could care less? So we do care. Then we could not care less. You could not care less. Okay. So we've got 5,000 grams of aluminum oxide. Okay. If you just want to write it like that, that's fine, because we know we're referring to this, aluminum oxide. All right. Ayo. Ayo, what's going on? Hey, and you guys, you didn't even break your face. It's still working. All right. See, we're not breaking our face. What is it, kind of like going out on a limb? I hope if I smile, please don't break. Please don't break. Still works. Okay, fair enough. 5,000 grams of aluminum oxide. So, 4 steps we need to accomplish. Okay, this is step 1. Anytime we've seen a substance in grams, we're going to change it to what? Every time. We're going to change that to moles, just like what we did in chapter 3. So, to convert aluminum oxide from grams to moles, we do a molar mass, which means what do we got to do with this aluminum oxide in this second step? Does grams go on the top or the bottom? Goes on the bottom. Okay. Grams of aluminum oxide. And when we add together these atomic masses, we would get 1 what? Okay, the example we gave in class would be is if we put 32.06 grams of sulfur in this cup, we have 1 what exactly? 1 mole. Why is that so important? Moles are counting units. That's right. So, you've got a mole of aluminum oxide, but we're leaving some space to put here because we need to add together the atomic masses. Each aluminum is how many grams, approximately? It says 26.9, whatever. So we're going to say 27. And each oxygen is 16. So 16 times 3. Okay. So we add them together. Got about 69 grams of aluminum oxide. All right. So our grams have canceled. Okay. Now, we're still stuck over here on this side with moles of aluminum oxide. That's not what we're looking for. We're looking for this mass over here. So, this next step allows us to change what we have, which is moles of aluminum oxide, into what it is that we're looking for. And that is what? Grams of aluminum, okay? So, if we've got a mole upstairs here, how do we cancel that out in our next step? Goes on the bottom or the top? Okay? Allows us to change what we have into what it is we're looking for. And this is called specifically a what ratio? It's a mole to mole ratio. What we have, moles of aluminum oxide to moles of aluminum. Anytime we see this, we got to go back to our balanced chemical reaction and put coefficients in there. So which one would go where? Okay, so we see this 4 here and this 2 here. So the 4 goes up here, the 2 down there. These have canceled. We've converted what we had into what it is we're looking for, but we're still in moles yet. So our last step, we see a substance in moles. Can we convert that to grams? Yes, and we did that also in chapter 3. Okay, so once we have this in moles, so for every mole of aluminum, how many grams do you get? Okay. Now, should we be in a hurry for some reason or another? We look at this. Why are we not doing that? Right, this is not a mole to mole ratio like it is here in step 3, because this is step 4. All right. So, take him back out of there. These have canceled, and this is why when you're showing that factor label method, you can look back at this and see exactly where it is you have, where it is you are, what you have, and what you need to convert it to. Okay, so we're left with grams of aluminum, and that's what we were looking for. So this tells us we are done. Because if the problem said if we had 5,000 grams of, or 5 kilograms of aluminum oxide, if it said how many moles of aluminum would that be, that's what you turned in today. We would know we would be done at this step. Why would that be? We don't need a mass, and we're ending in moles, and that's where we want to be. But it's not asking for moles, it's asking for grams. All right. So once we get that in that upper right-hand corner, we know that we are done. So multiply across in both cases, here and here, and then divide them into one another. But if you want to try to take a shortcut, what could you do with these two numbers? Cancel that out and just put what up here? 2. And that's okay. There's nothing wrong with doing that. Okay? Or you can just continue doing this exact same way, which is 5,000 times 27 times 4, giving you 540,000, I think. That's over. Almost a catastrophe there. 138. So 5, 4, 1, 2, 3, 4, divided by 138. Something's not right here. I did, and I wrote it up here, but I didn't take it times 2. I did that to show you where you can make a mistake. Yeah. Anyone believe that? Okay, you are exactly right. So 54 plus 42. 96 instead. 96 there. So now, top number's still the same. 5, 4, 1, 2, 3, 4 divided by 96. I didn't take it times 2, did I? No. 6 times 2. 192 goes down here. That one I caught before I went any further. Okay. Hmm. So 54 plus 4. Oh, I bet that's 48, not 42. 14 times 3 is 42. That's right. 48 plus 48 plus 48 plus 54. Is that what you said? 198? I added 48 twice. Okay. Okay. 102 is what we get there. Okay. 7 times 4. Did that already. 5, 4. 1, 2, 3, 4. Divided by. There we go. It says 2647. Is that what you get for an answer? Somewhere thereabouts. Okay. So what you're seeing here is what we call significant figures. And what it's saying is that some of these numbers, there's only 2 significant figures in here. And that is why they round that to 2,600 or 2.6 kilograms. So we want to have the answer of 2647. 2647. 0.06 grams of aluminum. All right. Left outside. Right middle. We good? Left middle. Right outside. Okay? Is it worth your time to do another one, or do you feel you're comfortable and want the rest of the time to yourself? Rest of the time for yourself? Okay. All right. We will catch up to you next time. which don't forget, your problem quiz just involves mole to mole problems, mole to mass, or mass to mole. Either 2-step problem or 3 steps. All right. Yeah.